Hello there everyone. Today we're going to be going over multiplication properties of exponents. By the end of this lesson, you should be able to use these multiplication properties to simplify your expressions. Without further ado, let's go ahead and get started. So, first we need to figure out what exactly is an exponent. Well, an exponent is what tells you that a number is being multiplied by itself a certain number of times. In this case, on the right over here, we have a base, or the number being multiplied, of 3. And we have an exponent of 2. That means that 3 is being multiplied by itself 2 times. In other words, we have 2 3's, which gives you 9. So here are some more examples that we can use to explain this. We have a base of 2 and an exponent of 3 in the first one. That means that 2 is being multiplied by itself 3 times. In other words, you have 3 2's, and that'll give you 8. The second one is the same thing, but this time the base is a variable. So we have a base of x and a power of 5. That means that x is being multiplied by itself 5 times. In other words, we should have 5 x's. Now, here's another cool little fun fact. Your calculator can do numerical exponents. Numerical just means that it's normal numbers. So it's not including variables like x or y, but it's including, normal numbers like -2, 3, 10, stuff like that. So in order to do these exponents, you can use this button. If you have a calculator that is using your keyboard, you should be able to make this sign by pressing Shift and then 6. If you have a computer keyboard in front of you, you should be able to see the sign on that keyboard. If you have a TI calculator or handheld calculator on hand that has this sign, that's what you want to press to get the exponents. So now take a moment to try it yourself. Get your calculator and see if you can figure out what these values are. I'll give you just a moment to pause the video. Alright, if you paused the video and you went ahead and did this, you should have gotten, for 2 to the power of 7, 128. And for -4 to the power of 3, you should have gotten -64. If you did that right, congratulations. Your calculator can do exponents. Great news, right? Okay. Now this second part down here, it's just one sentence, almost like it's a footnote. It is very, very important, okay? It says, always use the parentheses when working with negative numbers, as in negative bases. Now the reason for this is because depending on whether or not you use parentheses, you can get the right or the wrong answer. I can use -5 to the power of 2 to explain this. So one of these has parentheses, and one of them doesn't. Now if you go into your actual calculator and you do -5 to the power of 2 without parentheses, you would actually get -25. But if you do -5 to the power of 2 with the -5 in parentheses, you would get +25. I assume that the reason for this is because it seems like whenever you do a negative base with an exponent, your calculator doesn't read the negative as attached to the number. So usually the calculator just reads 5 to the power of 2. And then it does 25, and then it slaps the minus sign on at the end, like it's a bandage. But if you put the -5 into the parentheses, then the calculator reads, oh, okay, this negative sign is attached to the 5. So then it does -5 times -5 to get 25, which is correct because 2 negatives make a positive. So that's why you want to use parentheses, because the parentheses will ensure that you get the right answer. Okay? So very, very important. Just make sure that you're doing that when applicable, so that way you don't accidentally mess up your answer. Okay? Now, what if there is no exponent? Well, if a variable has no exponent, that means it has a power of 1. The variable is, just the base. So in this case, 5 is the same thing as 5 to the power of 1. And down here, a is the same thing as a to the power of 1. This rule is not on the formula chart. So you have to make sure that you remember it yourself. So just remember, if there's no exponent, that's the same thing as 1. Because remember, the exponent is the number of times that you're multiplying something by itself. So if you have an exponent of 1, that's just saying that you write the thing down, whatever value you have, down once. You're not multiplying it by itself any number of times. You're just putting that value down. So that's why exponent of 1 is the same thing as if you just didn't write any exponent at all. Alright, so in the past, you should have done addition and subtraction problems with exponents, where, you can only combine terms that have the same, you could say, level. Just imagine x, x2, x3, and so on and so forth, each have the same level. So you can only combine terms on the same level. It's what we call like terms. So here, we're adding 4x squared and 2x squared to get 6x squared. These both have x to the power of 2 in them, and so does the final sum, because they are like terms. So in these addition and subtraction problems that you've done in the past, the exponents do not change. They stay the same. Okay? But now we're multiplying and dividing exponents, along with some other things. But in this video, we're only going to be talking about multiplying them. But when you do these processes, the exponents are going to change. Okay? Now, these properties from your formula chart will tell you how the exponents change for each situation. This chart is actually the same one you will get on a STAR or EOC test formula sheet. So if you're taking your Algebra 1 EOC, you should have this chart. And it has some of the exponent rules or properties of exponents on it, which will be really useful. Now, let's get into specifics. This is the first exponential rule that we're going to be talking about. Product of powers. Now, the product of powers reads, if two terms with the same base are multiplied together, you're going to add the exponents. Here's the actual formula that you would find on your formula sheet. A to the power of m times a to the power of n equals a to the power of m plus n. So, with that being said, why does this make sense? Well, I'm going to explain it just right here. So we have x squared times x to the power of 4 equals 6. Now, once again, by the same rule that's shown right here, you are multiplying these two values, which means you're going to add the exponents of each value. So this is actually going to turn into x2 plus 4, which is going to give you x to the power of 6. And that's why that makes sense. We can see this property with another example. So, simplify a to the power of 4 times b to the power of 5 times a to the power of 2. So firstly, in this case, these like terms are going to be separated by variable. So I'm just going to rearrange all of this to, all have the same values, but this time I'm just putting the two a1s together, and then the b can go after. Now, the ones that we're going to combine are the ones with the same variable or the same letter. So this b, we're not combining anything with the b because it's the only value here, the only b value. But we have two a values. So here we can say that we take this a, and then we take the two exponents and we add them. So we add the 4 and we add the 2. And that is going to give us a to the power of 6. Now, we need to combine these. So we just did the a values and we got a to the power of 6. Now, this is the only b value, so we're not going to do anything else with it. We're just going to bring it down. We don't need to change it. It's perfectly fine as it is. And now, you can see our answer is a to the power of 6, b to the power of 5. Now, little break from the math for this slide, because this is a very important concept. You can tell by how many exclamation points there are. So, when you're working with exponent problems, you want to work with the coefficients separately from variables. The coefficients are the numbers, the real numbers, that are attached to the variable. This is because coefficients will follow the standard mathematical rules of, multiplication, addition, subtraction, etc., etc. But the exponents are going to follow, as we just discussed, their own special exponent rules. So you want to split them up because doing, say, 4 times 4 is very different from doing x to the power of 4 times x to the power of 4. Because in this case, when you're multiplying something, and you're usually doing 4 times 4, you're going to get 16. That's normal. That's how it usually is. But when it's an exponent, remember you're adding them. Even though it says multiply, you're adding them. So this is just one example. But the coefficients are the normal numbers that follow the normal processes. And the exponents follow their own processes. So you want to split them up so that way you don't do the wrong process for the wrong type of value. So now we're going to use another example, given what we've already learned and what I just briefly explained. So first thing we want to do is split the coefficients and variables up. We're going to start off with the coefficients. The coefficients are just the normal numbers you would see in like second, third grade, even like first grade. So we have -2 and we have 4. And obviously, because we have 2 pairs of parentheses with nothing else in between, this is just saying that they're multiplied. You can just imagine that there's a little, very tiny multiplication symbol right there. You can probably barely see that, but it's there. So we're going to multiply the -2 and multiply the 4 to get -8. Now, we can move on to the variables. We have two types of variables. We have x values and we have y values. So we're also going to split those up further. We have our x's that are outlined, and we're going to start off with them. We have x squared, or x to the power of 2, times x cubed, or x to the power of 3. Now we're going to bring in the adding the coefficients. So it's x, 2, plus 3, to give us that x to the power of 5. Same thing with the y values. We take the y's and we put them together. Now, remember what we talked about on that previous slide. Anything that is just by itself without any exponent is actually the same thing as saying it has an exponent of 1. So when we add these exponents, we're going to add the 1 and the 4 together. And that is going to give us y to the power of 5. Now that we have these values, we can shove them all together. Start off with the coefficient, then start off with the x value, and then add our y value together. So when we put them all together, we're left with -8 x to the power of 5, y to the power of 5, as our final answer. Now, it's time for a little bit of independent practice. Look at this problem and then choose the answer choice that you think is correct. 4 y to the power of 3 times 2 x to the power of 4 times 3 y to the power of 2 times x to the power of 2. So take a moment, pause the video, work this out yourself, and then see what the answer is. So, in this case, the correct answer choice would be B. And I'll explain why now. So, we start off with our coefficients. We have 4, 2, 3, and remember, something that doesn't have a coefficient in front of it, a variable that doesn't have a coefficient in front of it, is the same thing as saying 1. Because when you multiply 1 by something, it is just itself. Value times 1 is just that value. So x is the same thing as 1x, and x squared is the same thing as 1x squared. So we have our values. We have 4, 2, 3, and 1. 4 times 2 is 8, and then you do 8 times 3 to get 24, and 24 times 1 to get 24. Now, let's do our x values. So we have x to the power of 4 and x to the power of 2. We can write those out over here. And remember, in this case, we are adding those exponents together. So we do x, 4 plus 2, which gives us 6. So we have x to the power of 6. Same exact thing with these y values. We have y to the power of 3 and y to the power of 2. We can write that out with, the tiny exponents having the plus in them. And 3 plus 2 gives you 5. So you're left with y to the power of 5. Now, once again, you take these values, you slap them together. Bring the coefficient. Take this x value and slap it right on, and then add the y value. And you're left, final answer, of 24 x to the power of 6, y to the power of 5, which in this case, as we can see, is B. Now, moving on to our second exponential rule. This one is called power of a power. So, the power of a power says that if a term with an exponent is raised to another exponent, you are going to multiply the two exponents. You can see exactly what that's supposed to look like in a problem over here on the right, which is also what it'll look like on a formula sheet. So here you have a to the power of m in parentheses, and then you have the entire thing done to the power of n, which is the same thing as saying a to the power of m times n. Now, this says y does x to the power of 2, all done to the power of 3, equal 6x. So why does this make sense? Well, as you can see by the rule that we just learned, it's also right here on the third line of this exponential sheet. This x2 done to x3 is the same thing as saying x2 times 3. And then the 2 times 3 will give you 6. So, we can see this again on this slide. It's the exact same ruling. Here you have b, 3, done to the power of 4. That becomes b to the power of 3 times 4. Which then becomes b to the power of 12. As you can see right here. Now, here's another rule that goes with it. This one is known as the power of a product. It states that to find the power of a product, you can raise each factor to the power and then multiply. This is what it looked like on a formula sheet and in most problems. Here is a and b in parentheses to the power of n. And that's the same thing as saying a to the power of n multiplied by b to the power of n. In my experience, this works a lot like distributive property because it's essentially the same concept. You're just saying that anything that has this in this parenthesis has this n term attached to it. So the n is with the a and with the b. Now, we can use what we just went over in order to finish this problem by combining the two rules. So, we start off with the first one that essentially just says, okay, this to the power of 3 goes to this x value and to this y value. We can also just write it out over here separately. You don't have to do this if you find it unnecessary on your own, but I'm going to do it here so that way you can see my demonstration a little bit better. As you can see, we essentially distributed this cubic exponent, or exponent of 3, to both of the terms in the parentheses. Now we can use this multiplying exponents to state that this x value will become x2 times 3, and this y will become y4 times 3. From then, it's just normal multiplication, so this x 2 times 3 becomes x6, and this y 4 times 3 becomes y12. And then you just write them together like you would normally for your final answer, and you're left with x to the power of 6, y to the power of 12. Now we have some independent practice. So for this problem, we have in parentheses -3, x to the power of 2, y to the power of 4. All of those terms are done to the power of 4. Based on that, which answer choice do you think is correct? So pause the video, do the work yourself, and try to figure out which answer is correct. Alright, so in this case, our correct answer choice would be A. And I'm going to go ahead and explain why that is. So, once again, we start off using our first property to state that all the terms here, in this case 3 of them, are done to the power of 4. So we have -3 to the power of 4 x squared to the power of 4 and y to the power of 4 and then to the power of 4. Now, let's start off with our coefficient. In this case, if you do the math, you have -3. Let me write it over. Yeah, sure. I'll just do it over here. You have -3 times -3 times -3 times -3. Or -3 times itself 4 times, aka 4 -3's. If you do the math, -3 times -3 gives you 9. If you do 9 times -3, that gives you -27. And if you do -27 times -3, you're left with +81. So negative 3 to the power of 4 is 81. Now, we're going to work on our other values, going on to the variables. So, as we know in this case, we're going to multiply the variables. So we're going to have x 2 times 4. And that is going to give us x to the power of 8. Same exact thing with this y value. We are going to have y 4 times 4 to give us y to the power of 16. Now, we have our three values that we need, so we're going to take the exponents and the two variables, and we're just going to mesh them all together. Start with coefficient, move on to the x value, and finally end with the y value. So in this case, our answer is 81, x to the power of 8, y to the power of 16. Alright, I think that's enough to give a pretty good summary of multiplication properties of exponents. Remember to separate the coefficients and the variables of whatever problems you're doing. The exponent rules will only apply to the variable terms, not the coefficients. When you're working with more than one property, remember to use order of operations, aka PEMDAS, meaning parentheses first, anything inside parentheses first, then exponents, then multiplication or division, and then addition or subtraction. I mean, technically I could go on for a bit longer, but honestly this video is pretty long, so I think I should just cut it off here. I know this is only the first video about properties of exponents, and you might be thinking, almost 30 minutes just for one video, and you're telling me there's going to be more, but don't worry, because this video is going to be by far the longest one, okay? And that's because it's laying down a lot of the foundation, especially with the beginning slides, which took probably 10 or so minutes on their own. The next video in this series is going to be division properties of exponents, so look out for that and review it if you need to. Other than that, that's really all I have to say. So I hope you have a lovely day, and I hope this helped you out in some way. I just rhymed. That is awesome. Alright, goodbye everyone. Have a nice day.